With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Question is, if a direct current of value A ampere is superimposed to an alternating current of I equal to B sin omega t flowing through a wire, what is the effective value of the resulting current in the circuit? So here there are two current. This current here is I1, which is equal to A, and this current here is I2, which is equal to given as B sin of omega t. This here is our AC current and this here is DC current. So here the resultant, let's say instantaneous current, will be the sum of these two current, that is I1 plus I2, which here is given as A plus B sin of omega t. Now in the question it says effective value of the current. So effective value here means we can say here RMS value in full cycle. So we have the definition of RMS current, the effective current, as let's say I square, then we integrate this with respect to time. This is our mean value, and then taking square root. So this here is in one full cycle. Now here we can say this comes out to be, let's say, square root of, we can say this comes out to be our integration of I square, that is I here we have as A plus B sin of omega t into dt. This is whole square divided by, in the denominator there is integration of dt with, let's say here one full cycle. So this is 0 to t. So here we can say this simplifies to our square root of, we can say this comes out as, let's say, our A square plus we have here as B square, then there is sine square omega t, then there is our 2ab into sine of omega t into this here is dt. Now integration, and here with limit 0 to t, and in the denominator here this comes as t with limits as 0 to t. So this here comes out to be our integration of this here is A square into this is t with limit 0 to t. Next we can say this comes as B square and multiplied and divided by 2. So this here is 2 sine square omega t into dt, and then here we can say this 2ab comes outside, and this here is our sine omega t into dt with limits here 0 to t as well as here also 0 to t, and in the denominator there is t minus 0, which here is equal to t. So here integration and then square root of this whole quantity will give us the RMS value of the current. Now here we can see this is equal to our A square, this becomes our t minus 0 as t, this here becomes our B square by 2. Now we know here this is 2 sine square omega t is equal to, we can say as 1 minus of cos 2 omega t and dt, and then here this is 2ab, this here is equal to minus cos omega t divided by, there is omega with limits we can say here as 0 to t divided by, in the denominator there is t. Now square root of this whole quantity. Now on further simplification we can see here this comes out to be our A square, then we can see here this is our, let's say we can say as here this is equal to t, then here this comes as B square by 2, here integration of 1 is t and integration of cos 2 omega t is our sine 2 omega t divided by, we have here as 2 omega with limits 0 to t, and this here is 2ab divided by omega, and here this, let's say substituting the value, this comes as 1 minus cos of omega into capital T. So here we can divide by, let's say, capital T. So this here is our, let's say, square root of this whole quantity. Now on further, let's say integration, we can say here this comes as our A square into t plus we have here as b square by 2 substituting the limits t minus 0, and then here this comes as b square by 4 omega. Now substituting the limits, we can say here this comes as, let's say, sine of this here is 2 omega into t, and sine of 0 is 0, and this here is our, let's say, 2ab divided by this here is our omega, and then this here comes as, let's say, we can say here omega is equal to 2 pi divided by our t. Hence omega t comes out to be our 2 pi. So we can say here cos of 2 pi is 1. So this comes as 1 minus 1. So square root of this whole quantity divided by, we have here as t. So square root of this quantity. So now we can say here this further simplifies as, this here is equal to our a square into t plus this here is b square t by 2, and then minus of b square by 4 omega and sine 2 omega t. Omega t here is 2 pi, so sine 2 into 2 pi is sine 4 pi, which is 0 minus 0, and 1 minus 1 becomes 0, so this part here becomes 0, divided by, we have here as t. Now square root of this quantity, so we can see here these both parts become 0, so here taking t common for these two expression, hence this comes as a square plus, we have here as b square by 2, and square root of this gives us the RMS value or the effective value. Hence amongst the 4 options, we can see here our option number 2 is the correct answer. Hence we can say here 2 is our answer, that is the effective value of the resulting current in the circuit is root under a square plus b square by 2, hence 2 is our answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.